In this video, we are going to discuss about the H parameters for all three configurations. So, on the completion of this topic, the students will be able to analyze this frequency parameters BJT and the H parameters for all three configurations. So here in this H parameters for all three configurations, this transistor we are representing as the two-port network by making this any one of this terminal that is common between the input as well as the output. So there are three possible configuration where we are using this transistor. If there is any change in the terminal voltage and the current means, then there will be a change in the different transistor configuration. To find out or to designate this type of configuration, another one subscript which we are using as H parameter. So we can say that is HI is equal to H11E minus input resistance in the common emitter configuration. If it is forward bias means we can write this one as HFB is equal to H of 1B short circuit current gain in the CB configuration. So in this parameter you can be seeing that input resistance for CB configuration it is nothing but HIB and CE HIE, CC means HPE. Then reverse voltage gain means it is nothing but CB is, in the case of CB means HRB, CE HRE, CC HRE. Then forward transfer current gain means in the case of CB means HFB, in the case of CE is HFE, and in CC HFE. Then output admittance which is nothing but in the CB configuration HOB, HOE, and in the case of CC also HO. So you can see out the H parameters for all the three configurations here, that is CE, CC and CB. So in the case of the circuit is given as first figure is nothing but CE configuration. So to draw the hybrid model of this CE configuration, you are taking the base emitter region. So this base emitter region will be open circuited, and here this current will be flowing through this terminal. So here as if we know that it is HRE and this current direction is HFB. So based on that we are giving the current inductions, and also the output is nothing but the VC. And then in the case of CC means, then we know that is collector terminal is grounded. So from that this current flows through the circuit. This is nothing but HRE and here HFB, and the output will be the emitter voltage. And in the case of base, if the base is ground, in the case of CB configuration you can see that is base and the emitter region is present in the input terminal. So here we can take it as HRP, and in this current direction we can take it as HFB, and the output will be FVC. So based on this we are drawing the H parameters for three configuration. For CB, CC and CC configuration we are taking another one subscript which is nothing but the hybrid model of this configuration we are drawing like this. Next, to determine the H parameter from this characteristics, we are considering one configuration. Either you can choose any of the configuration. So here we are consider the common emitter configuration. So this functional relationship we can define as VB is equal to F1 into IB comma VC. In the term of current, if there is a change in the voltage means, then there will be a change in the current. So IC is equal to F2 into IB comma VC. So you can see the changes that they are denoted in this graph. So IB, IB1 and VB1, VB2. So from this graph it is indicated that whenever there is a change in the voltage, then there will be a change in the current direction. So this input characteristic curves that is giving the relationship between the base current as well as the VCE. So here you can find out the CE configuration. And in the case of the H parameter for all this configuration, we know that is the HIE, HFE, HRE and HOE. So to determine this value, that is HIE, you can write the equation as del VBE divided by del IB in case VC is constant. So you can write this equation as VBE2 minus VB1 divided by IB2 minus IB1. And in the case of HFE, so HFE means there will be a change in the collector as well as the base current whenever there is a whenever the collector emitter voltage is set as constant. So you can write it as IC2 minus IC1 divided by IB2 minus IB1. And in the case of the parameter HRE means there will be change in the base emitter voltage as well as the collector emitter voltage when this base current is set as constant. So you can write this equation as VB2 minus VB1 by VCE2 minus VCE1. And parameter in the case of HOE, there is a change in the collector current as well as voltage, collector emitter voltage when there is a change, when this base emitter current is set as constant. So you can write this equation as IC2 minus IC1 divided by VC2 minus VC1.